Okay, so I just want to start off by saying that we didn't have the idea or any of the code before this hackathon, so not throwing any shade, but we should be judged accordingly. Yeah, it's not a 3 months old. Cool. So the problem statement is that, like, you know, everyone and their mom is running some kind of RAG ad where you retrieve some context, and you, based on the context, you use it to answer the questions. And a lot of the time, the data source has, you know, tabular data, and, you know, data got jumbled up, and then it takes the data from the wrong row and wrong columns, and then it output the answer, very credible sounding answer. So what we wanted to do is to build a hallucination detection where we still answer you with the question that you asked, but also hit other open source models and cross-check the answers, and then flag it up to you if the answers don't agree with each other. Right. So Kitan's built an UI that we can talk more about.
So I guess one example is like, so this is just like, because we kind of think it's just a mock example, but like, let's say we ask, like, when was George Washington born? So like in this case, if it's hallucinating and it's not like interpreting the contextual data correctly, we run, like, I guess, several outputs across different LLM models and then compare the outputs across each other. And if it's inconsistent with the response, we flag hallucination and show the alternate responses that other models might have. So it's kind of like doing like a consensus check across different models. But then, like, if it's a question like, and like, if the answer is correct, then we don't need to show any other options. But yeah, so that's just like a quick, I guess, UX, UI process of what we envision to be.
So yeah, I worked on the sort of like truth detection LLM algorithm, and basically the idea behind it was to try to use an LLM as a very localized cognitive reasoning agent where it's restricted to the information in the prompt or context that has been retrieved from an external database, and you want to verify whether an answer generated probably by another LLM or maybe human is correct or not. Ideally, it's not actually using any information embedded in the weights. It's only using the local information that it extracted from, because that's what it can directly verify. And so I did this with basically just prompt engineering, asking it, given a question and an answer, maybe, you know, generated by some other LLM, is this true or not? And I was able to coax it reasonably well for certain use cases. It's actually a lot better when a human is making up some random answer that doesn't make sense rather than an LLM, because a lot of times the LLM will put in a lot of true information along with false stuff. So that was unfortunate, but you can see, for example, we fed it the attention is all you need paper and started asking questions. Some of them were things that were not contained in the information, like, am I wearing blue pants? With the answer, yes, obviously it's a hallucination, that's what's expected. In this case, the LLM was able to determine that it was in fact a hallucination. Another example is a specific blue score, which is correct, so it's 28.4 in the paper. That is not a hallucination, and these are basically a set of test cases that we checked. So we had maybe 10 different ones. Who's the first author? AGI House, unfortunately. Oh, actually, you got that right. So hallucination answer was true. The first author of the Attention is All You Need paper is, in fact, not the AGI House. And yeah, so who is the uncle of the first author? It got this wrong. This is a case where it did pull out the correct first author, so I think that's where it's getting confused. But here the response was, this is not hallucination, when in fact it should have no idea who the uncle of the first author is. It could be that somehow the LLM actually knows that. I don't know if this is really an incorrect fact, so maybe someone can verify that on Google, I don't know. Ash Vasari, yeah, so. Any questions? Yeah.
Good. Can you show your prompts for determining the consistency checks? Because I presume, like, your LLMs all output different types of different length, and you have another LLM that compares them and says these are the same or these are different.
So this is just for one specific output of an LLM. So it takes context, question, and answer, and it outputs whether it's a hallucination or not. So basically a Boolean. So this is the prompt.
In the URL, and then it will just keep growing in the number of models that it's crushing. Any other question?
Yeah. Which types of questions can you ask it, which it will hallucinate, and then it will also not know that it hallucinated? Like, have you thought about this? Is there like a certain type of question where it would just be, it would hallucinate upon trying to know if it hallucinated?
Yeah, I guess if you ask the questions and then it try to answer, and if all the models also answer incorrectly,
Yeah.
then that's like a super niche edge. Like, you know, like if you ask GPT 3.5 and then all across the board, Llama and Falcon and everybody
Right.
agreed, like also have come up with hallucination answer.
They're all pretty like different
see
on
that.
little math riddles. So if you say like there were like 3 apples, then we got like twice as many and we gave away half of them, how many apples are left? Every model will give a different answer. And like some might be right, but that's kind of for the case.
Yeah, so like we rank them, right? So similarity score, we rank for each of them. So the first one get 100 and then 90, 95, and then we'll just like, you know, show that to the user. So the user can sort of determine the thresholds, like, okay, if it's above 60%, I need to double check it, versus if they all agree, like in this case, then we're good. Cool, thank you guys for your time.
Thank you.